On page 228, you will find problem number 54, which gives us this equation and asks us simply to find all of the critical points. So I'm definitely going to need to take a derivative and find anywhere where that derivative is undefined or equal to 0. But what I want to do first is actually write down the domain of this equation, because critical points are supposed to be on the interior of the domain, so I feel like I need to know what the domain is. And what I see here are two functions that have been added together. And I remember that to be in the domain of that new function, I have to be in the domain of both of these functions at the same time. So I have to find this domain and see where they overlap. Well, for this first function, I have to be able to take the square root of 1 minus x squared, which means 1 minus x squared needs to be bigger than or equal to 0. And I can think about that domain by factoring the right-hand side and just thinking about a number line, because that's really an expression that says I need this to be positive or equal to 0. And I get two roots, 1 and minus 1. And in working with a polynomial inequality, I can just plug in sample points. And if I plug in a minus 2 from here, I would get a 1 minus a minus 2 is 3, times minus 1 is a negative number. So on this interval, all my y values would be negative. On the inside, I could think about plugging in 0. I get 1 times 1 is 1, and that's a positive. And on this side, if I plug in a positive 2, I'm going to get out a minus. The other way I could think about it is if I graph the function y equals 1 minus x squared, it's a downwards parabola with zeros at minus 1 and 1. So the only place it's positive is where it's on top of the x-axis. So to take the square root, I needed a positive or 0, so the domain of that part is minus 1 to 1. And nicely enough, when I look at inverse sine, I remember its domain is the interval minus 1 to 1. Nicely enough, these two functions had the same domain, so when I add them, those domains overlap everywhere. And so the domain of this function I've gotten through addition is from minus 1 to 1. And so now that I have the domain, I can think about finding a critical point. So let's take a derivative. First, I think I'll rewrite the square root part with an exponent. I know the derivative of inverse sine, so we'll just leave it alone. So I can use the power rule and the chain rule. 1/2 times 1, those would cancel. 1 minus x squared, take 1 away from the exponent, times the derivative of the inside, plus the derivative of inverse sine is 1 over the square root of 1 minus x squared. So we need to rewrite this. I'll have minus 2x over the square root of 1 minus x squared, and then plus 1 over the square root of 1 minus x squared. And I realize that very nicely these already have a common denominator. All right, I have my derivative, and now I need to look for it's either equal to 0 or undefined. It'll be undefined when the bottom's equal to 0, and I can quickly see that that's just the endpoints of my domain. So those aren't critical points because they're on the endpoints. Critical points are supposed to be on the inside. Let's set the top equal to 0. Take 1 away from both sides, and I have minus 2x is equal to minus 1. Dividing by minus 2, I get x as 1/2 as a critical point. The only critical point is x equals 1/2, because that's the only place where my derivative is either undefined or equal to 0 on the interior of this domain. The trick in this problem is I had to find the domain first, even though it doesn't tell me that. A lot of students will make the mistake of actually finding the critical points as all three things, never realizing those were endpoints of the domain.